الآن يمكنكم المشاركة في مبادرة الأيام الرقمية تحت شعار انطلق بقوة مع جوجل، والتي يتناول فيها خبراء جوجل عناوين جديدة أسبوعيا مثل السحابيات، مهارات من جوجل، أندرويد، فلتر، ذكاء الآلة، فاير بيس، ديزاين ثينكينج، مقسمة إلى دورات وورشات عمل يومية بالإضافة إلى مسابقات أسبوعية. شاهد الأيام الرقمية مباشرة على اليوتيوب وشارك رأيك وأسئلتك مع خبراء جوجل، واحصل على شهادة حضور في كل محاضرة تشترك فيها. هذا وأكثر من الأحد إلى الخميس ابتداء من الساعة 9 بتوقيت دبي عبر الرابط المبين youtube.com/gdgmena.
Hello everyone. Assalamu alaikum. I hope you're doing well and in the best of your health. Welcome in another session of MENA Digital Day sessions and another session in our series, the Path to Tensorflow Certificate series. In today's session, we will go with the third part of the computer vision. Okay, so for those who missed the previous sessions, we already talked about part 1 in computer vision and part 2. And of course, we talked about the whole path of the path to take the TensorFlow certification exam. Okay, so we are about to end with the series. Let's say we have about 2 or 3 more sessions, and like that, you will have the full path of, let's say, the full pack to pass the certification or the TensorFlow certification exam. Okay, so you are with Leyla Habib. I'm GDGCD Abbas lead and WTM ambassador. In today's session, inshallah, it will be like in a continuity about what we saw previously in this series, and especially in this computer vision field. So we talked about everything about computer vision. Let's have a small recap about this slide. Okay, so we talked about what's computer vision, when we use this computer vision in object detection, in classification, and so on. And of course, we saw many things about, let's say, colors, how we deal with color for images and grayscale images, how to extract data and features using the convolution. We saw the famous algorithm, which is the convolutional network. And we said that it's, let's say, a higher level of representation of an image using this convolution layer. So when we add the convolution layer to, let's say, when we add convolution to image, so it's allow us to extract or to derive features from this, from those text or from those images, sorry. And yes, it's basically used in images, but you can also use it in NLP or any other texture things. Fine, so this is about what we saw previously. Okay, so we said that this is the main architecture for the CNN or the convolutional network. Let's say we're having as an input an image. Okay, so image is only an example. We can use CNN in other format or in other data, let's say for text or anything else. Okay, so but basically it's used with images. Okay, so in the most cases we see that convolutional network or CNN is used with images, but let's say it's not like mandatory to use it. Fine. So we saw that this is the architecture or the path that the image will pass to do a simple classification, let's say whether this image here is a cat or a dog. So here we're having this input image, and then it will pass by a convolution layer. And in this convolution layer, let's say we will have or extract a totally new image. And from this new image, we can extract features and so on. Based on filter will be applied on this image. And yes, we do some convolutions. And by those convolutions, we can form or we can have a totally new image. Okay, and then we pass through the pooling layer, and we said that pooling layer with our model won't learn anything new, just or extract any new parameters, except that it will reorganize our data or reorganize our image and make it, let's say, it will divide it by 2. so that's it's sure that it extracts only the most important features from this picture. We have so many pooling layer. Let's say we have the average pooling, the max pooling. So it's take the max number from the that filter, and so on. And of course, the base of everything here is the dense layer. Okay, so everything will pass like we saw previously in convolutional network or recurrent neural network. All of them by the end they arrive to the artificial neural network, which is the base of everything. So here we're having a simple layers, dense layers, and of course an output layer to classify whether this image will be a cat or a dog. Okay, so this is the main architecture for convolutional neural network. Okay, so here the different filters that may be applied to detect anything, let's say to blur an image or to detect edges horizontally and vertically and so on. Okay, so this based on the filter applied on the picture. So let's say we're having this picture in the beginning. So based on the picture and the filter applied, we can sharpen image, blur, or detect edges and so on. Okay, so only the filter changed. And of course, the difference between feature extraction using filters, using convolution, simple convolution, and the convolutional neural network is here when we pass a filter through an image, it will give us a totally new image. Okay, so each filter will give us here 1 pixel, if you can say, or let's consider it as an array, so one number here in this new image. So it may look smaller. We saw so many techniques how we deal with that, and here is the equation how to get or how to know the new size of the image, because it's obvious that when we apply let's say a 3 by 3 filter on a 6 by 6 image, so here we will have, let's say, a smaller picture. And how do you know the new size of this image? Of course, by applying this form here, or by calculating this form here. Okay, so let's say the picture is more smaller to extract the most important things maybe. Okay, so we saw this example. So if anyone missed one of those, we explained them in details in the previous sessions. We talked also about padding. We said that there are some extra pictures added to an image so that it can conserve the same size of an image. Okay, padding, it's half. Let's say it's half the image, or it's allow. Let's say by adding this padding. It's allowed to, let's say, to make more accurate analysis to an images. Okay, so you will have, let's say, more accurate result and more accurate analysis. So we saw padding. Padding is those extra pixels adding to an image. And we saw also the stride. The stride is a number of pixels that our filter will slide by. Okay, so by default it's 1. So when we have this image, and by default the this filter will slide by 1. Okay, so that's what when we have the stride equal to 1, or the default one. But meanwhile, we can change the default number by adding let's say 2, so that my filter will slide by 2 or by 1 or by 3 as we decide, or as the programmer writing his code. So this is about the stride. Okay, fine. And this is an architecture to summarize everything. And here we arrive to our session. Okay, so before digging to our new session, it was just like a recap about what we saw in the first two parts of computer vision, because we already did 2 parts of computer vision. So if you missed any part, or you need any more details about those parts that we just passed through them, so you can just access the playlist, the TensorFlow, the Path to TensorFlow Certification exam playlist, and you can review the previous sessions. And of course, I may check the let's say the chat here. If any question, please, if you have any question, don't hesitate to ask here in the comments. Okay, fine. So today, inshallah, we will, let's say, continue about what we started previously, and we will talk about data augmentation and transfer learning. Okay, so when we talk about CNN or the convolutional neural network, here we need more data. Okay, so if you have more data, you can control better your model. Fine. So till this point, everything is fine. And we already said, or we already mentioned previously, that the more data we have, the better our model is. So it's good to have some extra data, some extra, let's say, if we are dealing with images, some extra images to train our model, or to at least can control it in a good way, on in good. But the question, how do I get more data if I don't have more data? Okay, so basically, if you have any problem, the first thing that you should do is to collect some data. At certain moments, there is no more data. So here, how can I do to get those extra data or to get more data? So generally, and in real-world scenarios, we may have a data set of images taken in a limited set of conditions, as you know. Okay, and our target application may exist in different or variety of conditions, such as, let's say, different orientations, different locations, scales, and so on. Okay, so let's say we're having the small amount of data containing a limited positions, limited orientations, but our targeted application, or the model that we will work on it, may need, let's say, more conditions, some extra or variety of condition in orientation, location, scales, brightness, and so on. Fine. So here we should find solutions by that. Okay, we account for this situation by training our neural network with additional modified data. Okay, so we can think about this data augmentation as some extra additional modified data that our neural network will use. Okay, so to put it simply, let's take an example to simplify things. If you are training a model, and this model have to classify, or let's say to spot cats from a batch of images, from a group of images, or let's say we have some few images, and we want to spot those cats from it. Okay, your model have never seen before how a cat looks like when it's lying down or when this cat is sleeping. Okay, so here by the weak our weak neural network, it might not recognize that in the future. Okay, so we trained it with a specific number or limited number of cats positions, and then when we test it with a new image, let's say a laying cat or sleeping cat, our model couldn't recognize that picture, that this is a cat. So in this case, here when we should refer to the data augmentations. Okay, before explaining exactly what data augmentations is, okay, of course, if you have any question, please don't hesitate to ask. I will check the chat from time to time. Okay, fine. So before explaining exactly what data augmentation is, let's talk about why is there a need for a large amount of data. Okay, so when you train a machine learning model, uh, what you're really doing is tuning its parameter, such as we can, let's say, map, yes, to link or to map a particular input or specific input. Let's say this input is an image, so we want to map this image with some outputs, a specific output, let's say a label, this image, to say that this image is a cat. So here our input is an image of, let's say, an animal, a cat or dog, and we want to link it with a specific output, which is, we call it a label. So those outputs are labels to say whether this image is a cat or a dog. Fine. So our optimization's goal is to chase that to spot where our models, let's say, yeah, to get the lowest loss function, the lowest loss, because we already mentioned before that the lowest our loss is, the better our model. Okay, so we always aim, or our goal is to get the let's say the minimum loss that we can get ever. Okay, and we can get the good loss function or the lowest. Sorry. So we can, let's say, this lowest loss function happen when our parameters are tuned in the right way. In the right way, sorry. Okay, so when we are tuning our parameter in a perfect way, in a good way, so here we will have a great model, a great result, and the mean, a lowest or a low loss function. Okay, fine. So naturally, if you have a lot of parameters, you would need to show your machine learning model, let's say, a part or a proportion amount of examples. Okay, so here we need some example to get to get good result or good performance by the end. Also, the number of parameters you need is proportional to the complexity of the task that you are working on it, or let's say the task that your model has to perform on it. Okay, so here is the let's say the keywords or why we need data. And we are not losing something if we're having a good amount of data. If we haven't, I can't see where is the problem of having so many data, especially nowadays we are living in the big data world, when there is a, let's say, a huge number of data. So it's good to build our model with a good, but of course with the condition that this is working with the right data or good data, because there is no meaning for having, let's say, for having millions of data with some, let's say, with some garbage in it, some data that useless data that can't help our model. Okay, so yes, it's good to have a great amount of data, but it's better to have a clean data or needed data. Fine. So here we said that the largest number or amount of data that we have, the better our results are, got the correct data. And yes, that's it. So that's why we need a largest data. And we return to our question. How do I get more data if I don't have that more data? Okay. So here in this, you don't have, okay, so let's say using here, while using, there are so many libraries and so many let's say easy things or easy codes to access or to use. So here in this part, you don't need to hunt for, let's say, so for more over new images. Let's say you are doing a model, you are creating a model that can classify images or can spot a particular image. Let's say to spot cats from images, from group bunch of images. So here to train our model, and they do have only a few number of data. So in this case, we don't need to seek or to hunt some other extra data. Okay. uh, why we don't need to seek extra data? Because neural network aren't smart to begin with it, but but we can, let's say, we can deal with it and we can handle it by having some augmented data or some extra data. Okay, so if we take this example, so for example, let's say in a poorly trained neural network, I mean, our neural network is not that good, and we don't call it a bad neural network, but let's say it in a poor neural network. Okay, it will think that this is three tennis balls here shown below in this picture. A poor neural network, we think that there are three different, distinct, unique images. So this tennis ball here is not the same as this one, and not the same as this one. Okay, so there are three. Okay, so here when we're talking about the poorly trained neural network. Okay, so to get more data, we just need to make, let's say, an alternation or an alternative thing to our existing data set, such as our model or our neural network would think that these are distinct images anyway, but let's say they have a link between it. Because here, let's say we're having only one tennis ball here. It's the same tennis ball, but in a different positions and a different shape. Okay, so yeah, that's the, let's say, the proper the best example for data augmentation. So here we just given out, so instead of training our model only about the same position of our tennis, so he will know only this ball, and maybe we can get a bunch of tennis or number of tennis balls there, and they will recognize him and will learn from them. But once we have another position or another, let's say, location for this tennis ball, it won't recognize it anymore. Because here, yes, we as a human, we can know that this is the same as this, just here, just like it's in moving shape or in moving situation. But our poorly trained neural network, we won't recognize this. Okay, so any questions so far? Please, if you have any question, please don't hesitate to ask. I'll be checking the chat for time to time. Okay, fine. So a convolutional network that can, okay. So a convolutional network that can, let's say, to robustly classify object even if it's placed in different orientation, is said that we have properly called something called the invariance. Okay, so it's thing which is well known in the convolutional network or the CNN, which is the invariance. So here we're having the same image but with a different shape or a variety of positions. Okay, so a CNN can be invariant to translate or to viewpoint, to size, or combination between all those things. And by the end, you will know that this is the same image here. Okay, so and this is the main point why we should augment our data. Okay, so in real world scenario, we do have some group of images, but in a limited conditions or in a limited variation. Okay, and as we said, we need to build a model that may work with a different variation, different positions, different scales, different size, and so on. Okay, so for example, if we want to build, let's say, a digit recognition system, and we give it okay, so this handwriting 6 here, and we trained our model from different 6, okay, with different handwriting, but all of them are the same position. So here my model might don't recognize that this is a 6 and this is 6 also. Okay, but by using this data augmentations, it may help our model to get those different conditions and some those new conditions and those new things. Okay, and here comes the role of the data augmentation, that it will be augmented or built automatically using neural network, of course, and some simple line of codes. Okay, fine. Here another example for data augmentations. So we try to link it to our real world scenarios so that all the examples will be clear. Okay, so here we as a human, we can by seeing those images here, we can recognize them directly that they are cats. Okay, and computer can do the same thing, especially if we train it good with a good amount of images. I always love to take the example of children. So let's take we have a small child, and this child, we just took them and tell him, yes, this is a cat. So this small child, let's say, will recognize this is a cat, and we'll save some features, let's say some characteristic of this cat. And in the next day, when we meet another cat, even with some different characteristic, it may recognize that this is a cat. But what if he met a cat this way? Let's say here sleeping in this position. So here is a mess. He may don't recognize this. Okay, because he's a child of, let's say, 2 or 3 years old, and he only saw cat walking, and he don't know that cat also can sleep. So he cannot recognize that this is a cat. Same thing for our damp machine. Because yes, we think that machine learning are smart, but they are not smart enough. So if I just trained my model on this kind of images, I'm sorry. So as I was saying, if we trained our model only about this kind of images here, so just by giving this model the new position for the cat, let's say a sleeping cat, it may not recognize it. And here where data augmentation became a must. Okay, we need data augmentation to give our model, to give our dump model a variety of positions. So even if let's say it's being tested or worked with a different position, it may recognize it. So if we want to define what data augmentation is, let's say the data augmentation is is the process of artificially increasing the amount of data. Okay, so we're having a few number of data. Using data augmentation, we will increase the amount of data, and we can also generate new data points from those existing data. So we just give our model this image here, and starting from, let's say this is the existing image here, this is the existing data. Sorry. So starting from this existing data, it can generate some more extra new data. Okay, it can flip it right, flip it left, zoom in, zoom out. Okay, so all those variation, it can be generated automatically using the data augmentations. Okay, so here my model can see a variation of positions, can see a cat flipped left, flipped right, zoom in, uh, rescaled, let's say shifted left, shift right, and so on. Okay, so here my model can see different positions for cats, and in the future when it will be tested by the same picture but in different position, it may not know it, or it may recognize it. Okay, so here is the main idea behind data augmentations and why we really do need data augmentation. Okay, it's help us to avoid the overfitting. So our model here will learn properly and in good conditions. Also, we may increase our accuracy, our model accuracy, just by augmenting our data sets. So whenever you want to fix your model, especially if you're dealing here with images, okay, it's not only for images, but it's okay. So we can augment our data set using this data augmentation to get some extra good accuracy in the future. Fine. So let's take this schema here. Okay, so here we're having our original data set. This is the original batch of images. Those images, so starting from these images, we augment it. Okay, and just to highlight this point, here we don't need some extra things in your local machine. So let's say if I augment my data set, so one image will be multiplied by 3 or 4. Let's say we're having about 100, yes, I think it's more than 100 parameter. I mean 100 variation we can do it on a single one image. So here in this case, you may wonder where to put all this data, especially if I don't have more space in my local machine. So the answer is you don't have to worry about the space you don't have, because nothing is happening in your local machine. You just let's think about it virtually. Okay, so only your model will see those augmented data set. Okay, you can visualize it, of course, but it's not saved in your local machine. The only thing that is saved in your local machine may be your data, your training data set, if you're not calling it from the internet. Otherwise, the augmentation the data set will be virtually, and then we fit our model with this augmented data. Okay, the augmented data only, not both, because sometimes we just start our philosophy saying that let's merge the original batches of the images with the augmented data set, and both of them we just fit them into our we just fit all those images. So you said that having extra images will be good for our model, but the answer is no, because here we'll map maybe an overfitting, because here we augmented our data based on the original batch. Okay, and we use only the augmented data. There is no link here between the original and the augmented data, so we forget about the original data set. In the next steps we will only use the augmented data set, and then by that said we can train our model and we can get better results, of course. Okay, is it clear so far? Okay, so we have some question from Muhammad. He's saying, I will just show the question here. He's saying how to apply to the Tensorflow certification exam, how to prepare for it. Does there Okay, so how to apply to the Tensorflow certification exam? You can directly access the Tensorflow certificate, the Tensorflow website. I may send you the link in the chat. Okay, so I may send you directly the link. So you are from YouTube. Okay, so in the comment you can find the website where you can apply to the TensorFlow certification exam, how to prepare for it. Okay, so you can just follow up this series we did. Let's say from last year, from 2021, we are speaking about the TensorFlow certification, so you can rewatch all those videos. And also I highly recommend to watch the Coursera, the Lawrence course from Coursera. It's a good fit for the exam. Okay, the other question is, does there is any reference to consult before taking the exam? As I said, if you want, let's say, a deep explanation, you can watch this series, this road to the TensorFlow exam, because we passed, we take, let's say, we took all the main things happening in the exam, or the main exercises in the exam. And also don't forget to check the Lawrence from Coursera course in the TensorFlow course of Lawrence. How long the exam take? The exam will take about 5 hours, but you're not obliged to finish all the 5 hours. You can finish, let's say, finish the exam before 5 hours. Okay, it's not the big exam. Okay, okay, I think that's all. I hope that I answered all your question. Okay, وعندكم. Yes, في الحقيقة session was supposed to be بالعربية. I'm really sorry, I just forgot myself. If you have any question, يعني إذا كان في أي نقطة لم تفهمها جيدا, just ping me in the comments and I can repeat it. I'm really sorry for that. يعني نعتذر على هذه المشكلة. قد نسيت أن هذه الحصة كانت من المفترض أنها تكون باللغة العربية. The link of the course in Coursera. Okay, so just give me 1 second. Okay, maybe I can just give me 1 second to check this course. Yes, it's the TensorFlow specialization. Okay, so just a minute to check this from Lawrence. Okay, I will share it in the comments. So اللينك راح نبعثه في الكورسيرا لينك راح نبعثه في الشات في الكومنتس for everyone who wants the Lawrence course from Coursera. Okay, so thank you so much. So إذا كان ما عندكمش أي سؤال تفضلوا أن نكملوا الحصة باللغة العربية or English. Okay, so it was supposed باش تكون باللغة العربية لكن يعني أخطأت ونسيت أنهى الحصة باللغة العربية. So تفضلوا أنها نكملوا باللغة العربية أو بالإنجليزية. والأشخاص يعني اللي ما كانوا يفهموا اللغة الإنجليزية إذا كان عندكم أي سؤال في أي نقطة من الأشياء اللي فاتت يعني don't hesitate باش تسألوا على هذه الأسئلة. Okay, fine. احنا راح نواصل والآن راح نشوفوا الكود. يعني احنا من البداية تاع السيشن ولا البارت تاع الكمبيوتر فيجن ما قمناش بأي تطبيق، فقط تطبيق تاع الهاند رايتنج ديجيتس ولا التطبيق الخاص ب the fashion amnest. Yes, we did together the fashion amnest. الآن إن شاء الله راح نشوف مع بعض الصور من الحياة الطبيعية، يعني من حياتنا اليومية. يعني في الحصص السابقة الصور المستعملة كانت صور كانت موجودة في كراس we just call it. يعني كانت data let's say كانت data set يعني مجهزة cleaned كل شيء فيها يعني جميل. هذه المرة راح نحاولوا أن نستعملوا another shape of data set. هذا الداتا set هي عبارة عن صور لقطط وكلاب. أوكي، صور لقطط وكلاب بأحجام مختلفة بألوان مختلفة، يعني كل شيء فيها مختلف. sorry. So just by calling يعني يمكننا أننا we call هذا الداتا set باستعمال هذا الرابط هنا. Okay, so let's execute this cell by cell. بعدها يعني هنا هذا الرابط راح يعطينا zip folder، يعني ملف بشكل زيب. ونحاولوا أننا نعمل له unzip ونحتفظ به في TMP فايل. إذا عندكم أي سؤال في أي لحظة يعني ما تردوش أنكم تسألوا. اوكي، سو هنايا بعد ما نعملوا له نحتفظوا ليه في TMP فايل. سو هنا it may take some time لأن يعني بمشكل في الكونكشن، لكن الأشخاص اللي عندهم يعني كونكشن مرتفعة يمكنهم أنهم بسرعة الخطوة تمر. الآن نقسم هذه الصور تاعنا، يعني نصنع فولدر للتريننج وفولدر آخر للفاليديشن. وسط التريننج فولدر راح نضع ملفين آخرين، واحد للقطط والآخر للكلاب، ونفس الشيء بالنسبة للفاليديشن فولدر. Okay, yes, of course I can share with everyone this collab. Anyone with the link? Cannot see changes. Fine. Okay, so here is the collab. Okay, fine. So هنا يعني فقط قمنا بتقسيم الملفات. هنا نلقي نظرة على الملفات، يعني محتوى تاع الملف. قلنا كنا في train cat directory. وضعنا فيها كات من الزب فايل. الآن يعني تشيك train cat directory، يعني الصور موجودة فيها، وجدنا أنها فيها كات رقم الصورة هذيك، يعني هنا دينا من البداية حتى 10. أوكي، سو 10 صور الأولى. أوكي، سو هنايا يعني عندنا 10 صور. نفس الشيء بالنسبة للدوج دايركتوري، قلنا أنه يعني يضعها في TMP file. so I think عندي مشكلة في الإنترنت اللي هالأمر راح تروح ببطء، لكن thanks God I executed this before the session, so everything will go smoothly إن شاء الله. So here we just count the total number تاع عدد الصور الموجودة في الكات images وعدد الصور الموجودة في validation cat images. okay, so في باش نعملوا training عندنا 2000 صورة، يعني عندنا 2000 صورة، 1000 صورة للقطط و1000 صورة للكلاب، وحتى نعملوا تيست عندنا 1000 صورة أخرى، 500 صورة للقطط و500 صورة للكلاب. اوكي، وهنا حتى نستعرض بعض الصور. Okay, I'm sorry, I'm having connection issue. This is a huge connection issue. So هنايا فقط حتى نستعرض بعض الصور. Okay, so بعدما نقوم ب execution لهذا السيل هنايا، يعني من المفروض أنها يخرج لي مجموعة من الصور خاصة بقطط وصور خاصة بالكلاب. but it's taking time، يعني هنا حتى عملية الداونلود يعني ما راهيش تحدث بطريقة عادية يعني أخذت كثير من الوقت. it's okay. الآن يعني راح نشوفوا most important thing في Convolutional Network. okay, so I shared يعني شاركت معكم هذا الرابط. أحتذر لأن عندي خلل في الإنترنت، لهذا يعني لا يمكن أني لهذا يعني لا يمكن execution ما تمر بطريقة جيدة، لكن شاركت معكم اللينك so everyone can try it by themselves. اوكي، قلنا الآن يعني نمر للمرحلة الأهم، وهي أننا وديزاين الموديل تاعنا، يعني كل هذه الأشياء اللي كنا شفناها في الحصة السابقة. يعني قلنا let's go back to the architecture. okay. لو قلنا في الاركيتكتشر الخاصة بنا راح يكون عندنا الانبوت لايرز. input layer هما هذه الايمجز اللي راح نعملوا لهم في داونلودينج هنايا، وديفايد them في كلاسترز وفي فولدرز. هذه للانبوت لاير. بعدها قلنا عندنا convolution layer. اوكي فاين. اذا كان جينا هنايا للجزء تاع ديزايننج للموديل الخاص بنا، السطر الاول قلنا أن هذه أول convolution layer. أول convolution layer. أوكي، قلنا باللي حتى نعملوا convolution layer يكون عندنا فلتر. هذا الفلتر هو يكون الدايمنشن تاعه يعني 3 by 3 فلتر. مثلا في هذا المثال هنايا هذا مثال تاع فلتر 3 by 3. أوكي، باش نقولوا باللي هنايا 3 by 3 قمنا بها بهذا الشيء. قلنا غالبا ولا في أغلب الأوقات يكون هذا عدد فردي، يعني الفلتر the size of the filter will be an odd number. okay, so either 3 by 3 or 5 by 5 and so on. هنا عدد الفلترز، لأن قلنا من قبل إذا كان يعني حاولنا نستخرجوا 5 features نديروا 5 filters هنايا. إذا كان حابين نخرجوا 32 feature نديروا 32 هنايا. okay, so هنايا it's up to the developer على عدد الفيتشرز اللي يحب أنه يستخرجها. and of course we use an activation function, and then here we force the input shape. okay, so قلنا أن هذه real world data set. so تمنيتكم يعني تمت ملاحظة هذه الصور، لكن it's okay, you can execute it by your hand. please everyone try to execute it حتى تشوفوا مختلف الصور. so إذا كان جينا يعني نشوفوا بمختلف الصور راح نلاحظوا أن الصور هذيك راح تكون بأشكال مختلفة. please you have the link in the chat in the comments. please try it, execute it if you have a good connection, and try to seek the image, try to check the images and you will notice that they have different shapes. So here with this comment here احنا نجبر هذه الصور حتى انها كلها تكون 150 على 150. and by saying here 3 معناتها انها هذه ثلاثة بايت مخصصة للالوان، لان صور القطط والكلاب اللي هي عندي هنايا هي صور ملونة ماشي صور ابيض واسود. اوكي اوكي فاين. بعدها قلنا مور ما نعملو convolution layer. الخطوة اللي تجي بعد الconvolution layer هي البولينج layer. هنا راح نقوم بعملية البولينج، وقلنا انها يعني بولينج layer تكون عدد فردي، تكون 2 باي 2، عادة ما تكون 2 باي 2، واللي تقوم بقسم الصورة على 2. إذا كان عندي مثلا صورة فيها 6 على 6 كي نقوم لها كي نضيف لها the pooling layer تصبح لي 3 باي 3. Okay, so this is in general the first convolution layer and the first pooling layer, and we repeated the same thing 3 times. Okay, so هنا يعني قمنا بعملية pooling layer واحدة أخرى، يعني يمكن أني نهبط ونرجعوا نفس العمليات الحسابية اللي شفناها في الحصة السابقة. يعني هنا في العمليات الحسابية كنا نقول هاي الصورة اللي عندنا قمنا بها قمنا بالconvolution layer الأولى، بعدها قمنا بالconvolution layer الثانية. بعد كل convolution ممكن أننا نضيفه pooling layer في هذه الصورة، يعني ما يشموه بحال pooling layer حتى نوصلوا للنورال نتورك الخاص بنا or this hidden layer or flattened layer. هنا يعني قلنا هنا convolution الأولى ثانية ثالثة. same thing here، هذه convolution أولى، convolution ثانية، وهنا convolution ثالثة، وفي أكيد بين كل وحدة كاين a pooling layer. of course قلنا هنا يعني dimension تاعها راهي كبيرة، لكن النورال نتورك الخاص بي يحب فقط one dimension. حتى نرجعها كلها one dimension نقوم بعملية الفلاتن، لأن هي في الأخير يكون عندنا مربع. نحاول أن نقوم بفلاتن. when we flatten هذيك الإيمج راح تكون عندها بعد واحد، وهذا البعد واحد يعني يسهل العملية للنورال نتورك الخاص به حتى يقوم بالعمليات عليه. الآن أضفنا وحدة hidden layer وهنا الأوتبوت layer. okay, الأوتبوت layer here درنا واحد. okay, output واحد. لماذا؟ لأن هنايا راح تكون الأوتبوت either 0 or 1. راح يكون الأوتبوت الخاص بي يا إما 1 أو 0. إذا كان 0 معناتها قط، إذا كان 1 معناتها كلب. okay, عندي only one output في النهاية. that's why we use the activation function called the sigmoid. we use it كي يكون عندنا binary classification. okay, هنا either cat or dog. كي يكون عندنا so many classes we can use the softmax or any other activation function. okay, it's really unfortunate to not seeing the just let me change the if I can change the network. okay, I think it will be better. Just let me run everything, because the summary is something it's something necessary to see, to check it, to understand better things, how things pass. It's really unfortunate. okay, you can all try it by your end, and of course if you have any question don't hesitate to ask it in the chat. okay, fine. okay, in the summary basically وش الاشياء اللي راح تحدث في summary. اول حاجه يعني راح يكون عندنا images ب 150. بعدها كي نقوم باول convolution layer يعني راح نقص الفلتر زائد 1. اذا كانت تتذكروا هذه العمليه الحسابيه، يعني احنا ما كان عندنا ولا padding، ما اضفنا ولا padding في الكود الخاص بنا، ما اضفنا ولا stride. so هنا padding equal to 0. so راح تبقى لنا في النهاية n ناقص f قسمة s اللي هو stride by default هو 1 يتسمى قسمة 1 زائد 1. so هنا n ناقص f اللي هي n عندنا 150 ناقص f اللي هي 3 لأن الf خاصة بالفلتر زائد 1 اللي تبقى لنا 148. يعني الاوتبوت تاع الكونفولوشن الأولى راح يكون 148. بعدها قمنا بماكس بولينج. قلنا البولينج لاير تقسم هذا الماكس بولينج تقسم الصورة إلى 2. إذا كان عندي 148 كي نقسمها على 2 تبقى لي 74. الصورة في الأخير هنا في النهاية تاعها راح تكون عندي 74. بهذيك 74 أو follow up with the same process، يعني نقص منها 3 نضيف 1 بعدها نقسمها على 2 وغيرها. اوكي حتى نصل في النهاية. اوكي so it's really unfortunate أنها ما تexecutaش but I sent you the link and by the end you can try it. And here is the okay, so here is just a summary to explain what's happening here. And then we compile our model and fit the model. Before fitting the model, we wanted to add the data augmentation part, because we said that maybe our model just get used to seeing some cats and some images like seeing in the prompt, and we want to rescale them or reshape them or shift them left or right or wherever. So حتى يكون عنده يعني العديد من الconditions وعديد من الorientations. So هنا نتعاملوا data augmentation، ويعني وفي نفس الوقت حتى we augment our data سيكون عندنا عدد أكبر من الداتا. So we rescale it. Okay, there are so many parameters، يعني كاين حوالي 100 parameter اللي نجموا أننا نتعاملوا معها حتى نغيروا في this في ال generated data ولا في ال augmented data الخاصة بنا. وبعدها باش نعملوا training we call those generated data. Okay, so here we do call generated data and not the original data. So هنا في الفترة تاع model.fit يعني يتم we call trained generated and the validation generated. Okay, so هذا بالنسبة how to fit our model. And then هنا يعني قمنا ب 15 epoch، يعني بعد 15 مرة راح يدور حول كل data set 15 مرة. Okay, which data set? The augmented data set. Okay, وبعدها يعني هنا فقط مثال راح يسألك أنك تدخل صورة. So you can go to Google any cat or dog image and you upload it here. Then once you upload it, it will be let's say راح يظهر لك النتيجة إذا كانت هذه صورة عقد أو صورة كلب. Okay, so إذا كان عندكم أي سؤال don't hesitate to ask, please. Ask in the chat. Okay, so since things are not working here, let's just go fast with the transfer learning. Okay, so here يعني أكملنا مع data augmentation. الآن شوفوا transfer learning. Transfer learning يعني هو نوع آخر يستعمل خاصة كي يكون عندنا يعني عدد قليل من الداتا سيت، واللي هو استعمال pre-trained model. يعني models كانوا تم تدريبها من قبل على شيء معين نستعملوه لتدريب على شيء يعني مشابه لهذاك الشيء اللي تم تدريب عليها في السابق. اوكي، يعني هنايا تزيد في النسبة تاع الموديل تاعك انه يقوم بعمل افضل. اوكي، سو مثلا اذا كان في الماضي يعني عملت موديل، this model يعمل لك prediction على هذه الصورة إذا كان الصورة تحتوي على محفظة أو حقيبة ظهر ولا لا. أوكي، هنايا من بعد في المستقبل جاك مشروع أنك تقوم بعمل موديل ليعمل لك ديتكشن إذا كان في الصورة مثلا سانجلاسز أو نظارات شمسية ولا لا. حقيبة الظهر والنظارات الشمسية both are objects، يعني كلها أشياء. أنت أيضا أول ما يطرح عليك هذا المشروع راح تتذكر أنك عملت من قبل على detection لحقيبة الظهر. راح يكون نفس الشيء تقريبا، فقط مغير داتا. كيف هنا كاين شيء آخر اللي هو transfer learning، أي لسنا مجبرين على أن نأخذ نفس العدد الأيام، لأن خاصة إذا كان عندنا صور ممكن أنها تأخذ عدد كبير من الأيام. في هذه الحالة لسنا مجبرين على أن يكون عندنا عدد كبير من نأخذ عدد ساعات كبير وإحنا نعمل training من جديد، فقط نأخذ البري تريند موديل تاع الحقائب الظهر، يعني الخاص بحقائب الظهر، ونطبقه على النظارات. لكن قد نطبقه على النظارات، هنا راح يستطيع بسهولة على أنه يتعرف، ولا بسرعة على أنه يتعرف يعمل موديل قادر على يعمل ديتكشن أو بريدكشن ما إذا كانت الصورة تحتوي على نظارة شمسية أو لا. أوكي، هذا what we call it the transfer learning. كأننا نقوم بتحويل مهام تم القيام بها سابقا. مثلا في الماضي عملنا تريننج لمحافظ لديتكشن لمحافظ، حتى في المستقبل يعني نقوم بها على any other object، يعني في نظارات شمسية أو حقائب صفر أو أي other object. أوكي، هي عادة أن في الموديل في اللايرز الأولى، يعني هي مقسمة إلى some layers. اللاير الأولى يتم التعرف فيها على الحواف، أوكي، واللايرز الوسطى يتم التعرف فيها على الأشكال، واللاير الأخيرة يتم التعرف على إذا كانت هذه حقيبة أو سانجلاس أو لا. الحواف موجودة في كل الأوبجكتس، يمكننا أننا ننقل هذا الليرنينج من الحقيبة إلى النظارات عادي، لأن كلها فيها حواف، أشكال، تعرف على الأشكال، كلها فيها أشكال. حتى اللاير الثانية قادر أننا ننقلها من الحقيبة الظهر إلى النظارات، فقط تبقى النقطة أن هنا يعني يعمل ديتكشن للحقيبة الظهر، وهنا يعمل ديتكشن للنظارات الشمسية. فقط هذه المرحلة الثالثة الأخيرة هي اللي تكون مختلفة. when we use transfer learning يعني أننا نقوم بإرسال تعرف على الحواف والتعرف على الأشكال، يعني اللاير الأولى واللاير الثانية، ونترك فقط اللاير الأخيرة اللي يتم التعرف فيها على الشيء الخاص، يعني حقيبة ظهر، محفظة، قلم، يعني الشيء هذا الخاص بذاته. اوكي، هذا ما يخص الترانسفير ليرنينج. هل في أي سؤال؟ هل عندكم أي سؤال so far؟ Okay, so we will, if you don't have any question, we will wait about 1 or 2 minutes and we'll end the lab, this session. يعني هذه هي. إذا كان عندكم أي سؤال لا تترددوا على سأله. أوكي، هل في أي سؤال؟ اوكي، بهذا يعني أكملنا درس النورال نتورك، درس ال NLP ودرس الكمبيوتر فيجن. يبقى لنا درس وحيد واللي هو تايم سيريز، نكمل كل مسار الترانسفير ليرنينج، تنسورفلو. إذا الآلة تتعرف على الحواف والأشكال فقط ولا تتعرف على الألوان، لا، هي في الحقيقة تتعرف على الأشكال وتتعرف على الحواف والألوان أيضا. لكن هناك قلنا في السابق، قلنا يعني هذه الأشكال ولا let's say الألوان لازم عليها أنها تتعرف، لأننا راح نضيفه totally new channel. كي نقول أن هذه صور ملونة، يعني أنا في الانبوت راح نظهر لها أن هذه فيها ثلاثة channels، 3 بايتس خاصة بالألوان. it's already احنا نعمله في الديزايننج للموديل تاعنا it's already knows that هذه الصورة فيها ألوان، وعادة كما قلنا في الدرس السابق ما فيهاش كل الألوان، فيها فقط 3 ألوان اللي هي RGB red green and blue. أنا إذا كان يعني في الخطوة الأولى أني I initialize it باللي هذه الصورة ملونة فيها 3، الموديل تاعي راح يتعرف أن هذه الصورة فيها اللون الأحمر والأخضر والأزرق. أوكي، هذا أمر مفروغ منه. إذا كان ما عملتش هذه 3 هنايا، يعني اللي تحدد لي إذا كان في 3 channels ولا لا، راح تلقائيا راح تأخذها بعين الاعتبار أنها صورة جراي سكيل. لكن ما يهم أكثر حتى نحدد شكل الحقيبة. هل شكل الحقيبة إذا كان أحمر ولا أخضر يعني it will matter? Of course no. يعني شكلها هو what mirror، شكلها والحواف أين تنتهي الحقيبة هي اللي تهم. لهذا هي الأشياء التي يتم انتقالها من في باستعمال transfer learning من pre-trained model، يعني موديل عملنا له training من قبل، إلى the current one، especially إذا كان يعني عندهم نفس التارجت ولا نفس الشيء، واللي هو أننا نعمله detection لشيء، لأن الحقيبة والسانجلاسز بوث أشكال. لكن إذا تقولي أنها تتعرف على الألوان ولا ما تعرفش، أكيد تتعرف على الألوان، لأننا هنايا قمنا بإعطائها metrics. هذا those metrics راهم already by 3 bytes، adding the 3 bytes to say this is a colorful image. لكن الألوان بالنسبة لها هي فقط هي RGB بنسب مختلفة. نتمنى أني جاوبت على سؤالك. Any other question؟ ولا يعني أي إذا كان PLM، إذا كان يعني عندك إضافة أخرى. أوكي so إذا كان ما عندكم أي سؤال، شكرا جزيلا على هذا الحصة. نلتقي في الشهر القادم إن شاء الله مع آخر دروس واللي هما التايم سيريز. شكرا جزيلا، مع السلامة، إلى اللقاء.